In this problem, we have a ball rolling down an inclined ramp. We don't know the slope of the ramp, but we do know some information. So we're going to start with our motion diagram for this encounter. So if I do just a general sketch of what's going on, I have some sort of ramp with a ball on it that's going to be rolling down. And again, I don't know what that angle happens to be. But I do know how these balls behave as they go down ramps. So it's going to start at rest. I'll mark that as 0. And then it's going to move downwards along that angle. And at each point, its vector is going to get a little bit longer. So we're going to assume these are the velocity vectors. And we can go through and label them at 4 different points there. Because those vectors are getting longer, that means that I'm assuming the acceleration is in that direction. And because of the specifics of this problem, I'm going to choose to make that direction my positive direction, because I can choose whatever I want. So this is my motion diagram and my sketch for this particular problem. I also need to go through and look at the problem itself to look at what my knowns and unknowns happen to be. So my knowns, it tells me that the ball was let go at the top of an inclined ramp. So I can make the assumption that that initial velocity, v at that point 0 over here, was 0, meaning that it started from rest. It also tells me that it took 3.8 seconds for it to reach the bottom of the ramp. So let's assume that my point 4 that I have marked here is the end of this ramp. So that means that the elapsed time between position 4 and position 0 is that 3.8 seconds. So I'm going to use the subscripts to try and denote what the 2 different positions are, my starting position and my final position. And then lastly, it tells me how fast the ball was moving when it got to the end of the ramp, which again, I'm labeling as position 4. And that was 9.7 meters per second. So what are my unknowns? I don't know what the acceleration is. I do know what its direction is, but I don't know what its magnitude happens to be. And I don't know how far it traveled, meaning I don't know how long this ramp is. And because it's a ramp, I'm going to use s as my distance variable instead of x or y. I often personally like to use s when it's kind of ambiguous or if it doesn't really matter. So I have my problem set up. Now I'm ready to go through and start to solve it. So my questions are, what is the length of the ramp? So the end result of what I'm trying to go through and figure out is this delta s from from 4 to 0. So in order to go through and do that, I do need to figure out what my acceleration is first. So how can I go through and do that? Well, I know that acceleration is equal to the change in velocity over the change in time. If we were doing calculus, this would be dv dt. But since I've got discrete values here, I'm going to focus on this part. And so what this is telling me is that if I've got a velocity at, say, position 4 minus the velocity at position 0, divided by the time at position 4 minus the time at position 0, then I can go through and figure out what the acceleration is. And luckily, I already have that information. So my velocity at position 4 is 9.7 meters per second. My velocity at position 0 was just 0. And the time between position 4 and position 0 is just my elapsed time. So that's the 3.8 seconds. So that means that my acceleration here is going to be 2.55 meters per second squared. Now that I know what my acceleration is, I can go back to use one of my other kinematic equations to figure out what this overall distance happens to be. So I'm going to use the acceleration to find the delta S that I'm interested in. So I'm going to use the kinematic equation that looks something like the final velocity squared is equal to your initial velocity squared plus 2 times the acceleration times the distance traveled. I'm going to switch this into the notation that I'm using here. So this one would be v sub 4, so the velocity at that position 4. This will still be v0 plus 2a delta s subscript 4o there. So what I'm trying to go through and solve for is this piece here. So I need to go through and do a little bit of algebra to get that separated. All right, so I also know that this velocity v sub 0 is 0, so I can go ahead and make that disappear. And now I'm ready to plug in my numbers. So again, the velocity at that fourth position was 9.4 meters per second. That'll be squared over twice the acceleration I calculated. We can see that all of my units are going to cancel except for an m on the top, which is good because this is a distance. And so if you plug that into your calculator, you'll find that the distance was almost 18.5 meters. So this was a very long ramp that this ball was rolling down.